Hi, this video is to take the place of a lecture because I am not going to be here today on Tuesday, April 10th. So this is in your CAT packet that you got on Monday, that you did the lab yesterday. You did an example on exothermic and endothermic dissolutions. We'll talk about that more on Thursday when I get back, but let's go to, there's a page in here that looks like this, place for some notes. A lot of this stuff is pretty basic, the stuff that you probably would have covered in middle school, but I do want to run over this just in case you need a refresher. First of all, thermochemistry, again, the gives it away just by the name, heat chemistry. Yeah, this is the chemistry when we do reactions, the changes that occur in energy and heat. Now remember, law of conservation of energy. We've already talked about the law of conservation of mass or matter, that matter can neither be created nor destroyed. It's only converted, same way with energy. So energy can either be converted from one type to another. So let's talk about three. There are more than this, and kind of get a bit more kind of like, they get more specific, but these are the ones that we're going to be talking about. In general, potential energy is it's the energy of position or composition. Energy of position or composition. And what I mean by that, if you have a mountain, yes, that's a mountain, don't laugh. And a rock on the mountain, yes, that's a rock on a mountain, don't laugh. And if somebody lets this go, what's going to happen? It's going to roll down the hill, right? Well, how high that rock was on top of that mountain is the energy of position. It's the amount of potential energy of how high it is. So that's one type. Energy of position is a type of potential energy. But that's not so much how we are going to, that's not so useful in chemistry, is this whole height and gravity thing. What's more is composition. If you take a glucose molecule, which is C6H12O6, that's a lot of different bonds in there. It's actually a 6-carbon chain, so they're kind of like all combined together. Then you have the oxygens and the hydrogens all combined, or all attached to the outside. I'm not going to go through the specific structure, but that's a lot of bonds. That's a lot of bonds in there. So what happens is there is energy, potential energy stored in those bonds. It's the composition. It's how the electrons are arranged to make it more comfortable. So it's the energy in the bonds because of the position of the electrons. Now what happens to glucose is something like that. When you eat it, your body has a very complex type of enzymes and mechanisms that are going to release all of that energy out, and then it's actually going to get reformed into what? Well, it's a combustion reaction. What are always the products of combustion reaction? Carbon dioxide and water. But this is at a lower energy. This is a high energy, okay? High energy, low energy. And so the difference in energy is potential energy, or excuse me, it's stored as potential energy, and then it's actually going to end up being released as thermal energy. Okay, but it's the energy stored in these bonds that's potential energy. Okay, let's talk about the next, kinetic energy. Kinetic energy is the energy of movement. In the case of chemistry, we're talking about the movement of molecules. So if the molecules are moving faster, they have more energy because they're moving faster. If they're moving slower, they have lower energy because they're moving slower. Okay, so that's how kinetic energy works. And then, of course, we have thermal energy. Thermal energy is what you think of as heat. And what you need to remember from that is that heat always flows from hot to cold. You know, when you put your hand on a hot burner, the heat is going to go into your hand. It ain't going from your hand into the burner. So I always think, remember, it's to hot to cold. Now, one kind of misconception people, temperature and heat are not the same thing. Let's talk about how they're different. Heat is this thing, this actual type of energy, this thermal energy. It is energy. Temperature is just a record of how fast the molecules are moving. Okay, so it's just a record of how fast the molecules are moving. So if the molecules are moving faster, like in this fast, high energy, that means you're going to have a higher temperature because it's telling you how fast the molecules are moving. If they're moving slower, that means you're going to put in your thermometer, it's going to record a lower temperature, okay? So they're moving faster because of the higher energy, so the higher the temp. If they're moving slower, the lower the energy, the lower the temp, okay? But temperature is not heat, okay? All right, exothermic reactions. These are reactions in which they release heat. Now, where do they release heat from? Well, first of all, I have a couple pretty, well, for me, good diagrams on the sideboard, so make sure you look at the sideboard if you're confused on this. But exothermic reactions is when you have some sort of reaction that releases heat, and let's say it's the combustion of methane. A combustion reaction is a hydrocarbon plus oxygen, always, 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 yields carbon dioxide and water. And what ends up happening, so your methane and your oxygen, you're starting off with this, and these are two relatively high energy molecules, okay? So if we put potential energy, PE, potential energy, I abbreviate that a lot, PE, potential energy, KE, kinetic energy, okay? Both methane and oxygen have quite a bit of potential energy stored where? In these bonds. So then what happens when you get that spark that gets it up and over its activation energy, we'll talk about that more kind of in Chem 2, but it gets up and over, then it makes carbon dioxide and water, which carbon dioxide and water, you can think of these are chill. These are just chilling out molecules. These are very high energy, and these are just chill. Well, where does the extra energy go? All of this energy that was stored in here and not reassembled into the carbon dioxide and water, well, they go out as heat, and we use that to heat our house or cook our food or use as Bunsen burners, whatever, but that heat is what comes out, and it's the difference between the potential energy of the reactants and the products. Remember, reactants, products. Now, endothermic reactions are going to be the exact opposite, okay? In this case, let's say, again, on my sideboard, let's say we have ice. Ice, which is solid water. In order for it to melt, it's going to need to absorb heat, right? If you want liquid water, it has to absorb heat because you're going from, first, okay, if you think about it, the ice, okay, the molecules of ice and in water are they're not moving very much, right? Not moving, they're just kind of there. In order to become a liquid and move more, they have to absorb heat. They have to absorb heat to move the molecules faster. Okay, so that absorption of heat is going to be turned into kinetic energy so that they are moving faster. So that means this is an endothermic reaction because it absorbed heat in order to become a liquid. So you can think of this in these next couple worksheets as you're doing. First of all, I want you to go ahead and kind of think about this, okay, and answer these. This has to do with what we just talked about. And then go through and tell me whether you think these things are exothermic or endothermic. Okay, let's go through this first one. An ice cube melts after being left out on the table. Well, what is the system? The system, of course, is actually what it's being worked on, and that's going to be the ice. And if it melts, that means it's going from a solid, okay, so going from a solid to a liquid. Which one has higher energy? The liquid does, because they're moving faster. So to go from here to here, it has to absorb heat, so it's endothermic. So it absorbs heat to become a liquid, which has higher kinetic energy because it's moving faster. Okay, so then go ahead and try these out. So, so your assignment for today, okay, go ahead and try this, try that out, and remember, refer to the sideboard if you need it. Okay, good luck with that. Bye.